All right, so this is the note for U1L15, and we are interpreting the graphs. So our objectives would be to solve real-world problems using the graphs. So our first example is going to be another very similar word problem. We have water being poured into a large container, and the container already has 5 gallons to begin with, and the water is being poured in at 2 gallons each minute. Okay, so it's the same format of word problems that we have dealt with this entire time. You see that we started out with 5 gallons, and then there's the rate of 2 gallons each minute, or 2 gallons per minute. You guys know those words that we're supposed to look for. Okay, so let's define our variables. There are two variables in this problem. So x represents the time in minutes, and y represents the amount of water in the container, which would be the gallon. And then the equation, of course, is going to be y is equal to 2x plus 5. I think that would be, um, very basic for you guys at this point. Okay, 2x because 2 gallons each minute, and the 5 is because it already started with 5. So we're going to graph this, right? So word problems, it gives you an equation. You can use this equation to graph to represent what's happening. Okay, so my x is my time. So all these numbers here are minutes, right? 1 minute, 2 minutes, 3 minutes, 4 minutes. And the graph is going to show what's happening at each of those minute or all those time across this x axis. And the y axis here is, of course, going to be your amount of water, right? So the amount of water in gallon is going to be all these numbers. And then the graph should tell us at 1 minute, how many gallon would there be, right? At 2 minutes, how much would there be? And so on. So I graph that. I start at 5, and the slope is 2, so it goes up 2 over 1. There is my line. Okay, so we're going to use the graph to determine how much water would be in the container at 4 minutes. Now, when they give you the 4, and you have to decide, is that 4 the x or the y? Right? It says 4 minutes, so x is the minutes. I go to 4 in my x-axis right there, and I look toward my my line. So I look straight toward that line, and it's at that point. Okay, at 4 minutes, my graph is there, and then from then I look to the y-axis to see how much water would there be, because the y is the amount of water. So I look across here, right? That point is the intersection of 4 minutes and 13 gallons. So that's how I know it's going to be 13 gallons, right? 13 gallons at 4 minutes. And then here, we use the graph to determine how long it would take for the container to have 10 gallons of water. All right. So we look at the value that they gave us. They gave us 10 gallons. So 10 gallons, that's for amount of water. It's going to be my y-axis, right? I go to where 10 is on the y-axis, and I look toward my line. So there it is. It's right there at that point. And from that point, I look toward my x-axis then, right? And it's about right there between 2 and 3. Again, when you use the graph, sometimes you have to estimate, because not everything is always at the corner at whole number, so you have to kind of estimate, right? So it's between 2 and 3. I'm going to say it's about 2.5. Okay, so 2.5 minutes. And the only way for us to really know for sure, is it 2.5, is it 2.3, 2.4, is to use the equation. The equation can give us the exact answer. So I'm going to use the equation, y is equal to 2x plus 5, and they gave us 10 gallons, and gallons is y, so I put 10 in for y. So I have 10 is equal to 2x plus 5, and I solve for x. So I subtract 5 on each side. I have 5 equals 2x. Divided by 2, I have x is equal to 2.5. So our estimation is basically on point. It's at 2.5 minutes. Okay. Another example I would have is the water is leaking out of a large container. The container had 13 gallons when it began, and it leaks 1 gallon every 2 minutes. Okay, 1 gallon every 2 minutes. Now, this problem is slightly different from what you guys are used to. Okay, but we'll start out with the variables again. X is going to be the time in minutes, and Y is going to be the amount of water in the container. The equation. First of all, you have to 13 is your number in the back, right? The B. because you started out with that. But it's leaking 1 gallon every 2 minutes. Now, normally we're used to like 1 gallon every minute, 3 gallons every minute. That would be your slope. However, the slope now is going to be 1 gallon every 2 minutes. Remember, slope is the change in the y over the change in the x. Okay, so which one is the y? The water, right? So the water, the change in the water goes on top. That means the gallon goes on top, one on top, and the minutes at the bottom. So one over two would be your slope. So my equation is negative 1/2 x plus 13. Again, the slope is the change in the y on top and the change in the x at the bottom. So 1 on top, 2 at the bottom, because water is y, minute is x. Okay, and it's negative because it's leaking out. It's losing. You're losing that much water. Now I'm going to graph this. So I start out at 13 and I go down. Oh, by the way, x is still time, y is still amount of water, and then I go down. Right, from 13 I go down 1 over 2, down 1 over 2, and there's my line. Now I use that to answer the questions. Right, so they want to know how much water we have at 5 minutes. Now 5, it's minutes, that's x. I go to where x is 5 right there, and I look toward my graph. It's at that point. Okay, now I look toward the y, and it looks like it's between 10 and 11. I'm going to say it's 10.5. Okay, again, it's in between 10 and 11, so I'm estimating. I'm not sure if it's 10.5. I'm going to use the equation to make sure. So I use that equation, and it says 5 minutes, so I put that in for my x. So negative 1/2 times 5 plus 13. Negative 1/2 times 5 is going to be 5 over 2. 5 divided by 2, which is negative 2.5. Plus 13, which gives me 10.5. Okay, so again, our estimation is correct. It's 10.5 minutes. The next part, use the graph to determine how long it will take for the container to have 7 gallons of water. So 7 is the y because it's gallons of water. So I go to where 7 is on the y-axis and I look toward my graph. It looks like it's at that point, which would be 12 in my x-axis, which would be 12 minutes.